Good afternoon, good morning, or good evening, depending on where you are in this world, and thank you for joining today's webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. Before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, please know that you will receive a link post-event via email that you can use to access the webinar on demand. And today's event also, we will be taking audience questions. That's it. And so if you have a question at any time during the event, please just use your control panel, submit your questions. Hopefully we'll have about 15 minutes or so near the end of the presentation, and we'll go through the audience questions at that time. Okay, and with that, I'd like to go ahead and introduce today's webinar, which is integrating security into your CI or development pipeline. Our speaker today is Jenkins Gibbons, who is the Senior Solutions Architect at Cloud Passage. Welcome, Jenks.
Thank you very much, Charlene.
Thank you.
So good day, everybody. My name is Jenkins Gibbons, and I'm happy to be here with you guys today. Firstly, I would like to thank everybody for joining. I know that everybody's busy, and I think that we have a fun half hour here coming up to talk about security and bringing it into DevOps. So I'm going to start out by just giving a brief introduction for myself. So I've been in the security industry on and off since, I guess, about the early 2000s, doing work related to encryption, to infrastructure security. And where I've been focusing really sort of over the last few years is automating infrastructure security into CI/CD processes. And so let's jump into it. So today, as we mentioned, we're going to talk about integrating security into a CI pipeline. So I think this is going to be a fun half hour, like I mentioned. We had a webinar back on November 2nd of last year. And as I started to prepare this webinar, I noticed that this is actually a bit of a continuation from that. So what we focused on in that webinar was infrastructure security from a host standpoint. So looking at the operating system above the hypervisor, in any environment, whether it's public or private cloud infrastructure or whether it's bare steel. And today we're going to look a little bit more at containers and container images and extending our infrastructure security into that realm. But before we get started there, I thought it might be helpful to go back and do a little summary of what we talked about earlier in November, and we can also reference that webinar if you want to go back and look at that in detail. So where we started was just sort of looking at the idea of whether security is a roadblock for continuous delivery. And I've seen it be a roadblock. I've heard people talk about, from a DevOps standpoint, we're really trying to move fast and we're being blocked, by these SLAs that are provided by security, and just things aren't matching up between the teams. And what we're going to look at is how we can break those roadblocks down. So what I've traditionally seen is a security gate at deploy. So we've got a team that's working at deploying fast. They understand what the business units and what the end customers ultimately want, and they're working on providing that to them very quickly. And when it comes time to deploy, all of a sudden they run into a roadblock of, well, we need a scan on the image, 5-day SLA. We need firewall rules, 5-day SLA, and really hitting a block at that point. So what we're going to look at is how we can implement some security guardrails and put security automatically into the process so it's not blocking deployment. So we're going to start out by looking at this helix and sort of how we can implement security continuously, starting out with planning. And planning takes people, where we're looking at the different types of systems and how different systems fit into the same security area. So you have security posture that fit a certain amount of systems, and they can go into the same group so the security can be applied to all those automatically. So automatically implies when a system comes up and it's created, There's a security system. For example, we use a very small agent, whether it's public, private cloud infrastructure, or bare steel, that can be installed using typical orchestration tools like Chef, Puppet. It can be integrated into your Packer process, whatnot, so we can automatically install that to automate the security. The verification is generally the verification of a golden image, for example. So I have a machine image, and I know that when I created this, there weren't any software vulnerabilities. The configuration matched CIS benchmarks. The server accounts were in tune with what I'm looking at, and I can verify that during my process. So for example, when code's checked in or at a certain time at night or whatnot, because data is being continually updated, for example, NIST data or SecPod data. As we move forward, this is pre-prod, and we're going to be looking at policies for pre-production. You know, we don't want to push out with any critical software vulnerabilities. We don't want to push out with default passwords, for example, in configurations. So we're going to look at those things before we release. So what we're looking at here is proactive and continuous security. So as we move forward, we'll configure these for production. So for example, automatically moving things into production as builds pass. So there are no software vulnerabilities, configuration issues. For example, we can move it then into a security group, which may change the firewall rules, which may go ahead and take a file integrity baseline, so we can then monitor if any critical files change. And at that point, we can go on to monitoring, where, just like I said, we can monitor files to make sure that no files change. We can look at new vulnerabilities that have come up, so we can automatically remediate using Puppet, or we can go ahead and replace the instances that have outdated images. So some examples of how we can put security into this DevOps process. So just a quick recap of what we talked about. So, and as I mentioned, November 2nd, 2017 was sort of a first part of what we're doing today. It talked about mostly host infrastructure security. And like I said, we're going to go into Docker security today. So as far as images and containers go. But what we talked about was, we talked about Acme Incorporated, so fictitious company. And we talked about how they were delivering twice a day using CI/CD, autonomous teams, and that security was blocking the speed of business. So they're ready to deploy, and all of a sudden there's a Jira ticket, there's a Snow ticket that says, you know what, 5 days, we need to have a scan, we have 5 days to do this. All of a sudden your delivery has been decreased by 5 times. So as we move forward, what we're doing is we have a process where people are pushing out code very quickly, and we have a set of tools that are being used. And rather than hours, what we're looking at here is days. So we want to increase the speed of that. So what we talked about, and like I said, I'm moving over this very quickly because this is sort of a recap of what we're going into. If anybody has any questions at the end, please feel free to ask. So what we talked about was adding a security team member to the DevOps team. So get everybody working together. And then add security into the process. So for example, we have somebody that checks in some code into Git, and let's say there's a hook into Jenkins, and we go ahead and check our infrastructure at that point. So we make sure that there are no software vulnerabilities, make sure that there are no configuration issues based on CIS benchmarks. And we do this by using, for example, Chef Test Kitchen to kick off an instance of the golden image, run the scans, and then give direct actionable feedback, for example, through Slack, that says we're decreasing that feedback loop. And for example, it says you've got a critical kernel vulnerability, and it's at this time. We have an audit log that's been checked into Git, and we can take action on that, evaluate it. For example, it could automatically open up a Jira ticket, get assigned remediation. As the remediation happens, the infrastructure is checked back in as code. This kicks off yet another build for a reevaluation, and you have an audit log of the issue found at this time, the issue corrected at this time, and you know exactly the state of your infrastructure. So we've had customers that have noted that this process has really enabled them to take patching critical vulnerabilities from hours or days down to minutes with an auditable record of that. So what we're looking at here is, for example, writing the code, going through, triggering that. I would swap those tests in the scan. No reason to run the security scan if your tests are going to fail. If it passes, then you're going to go ahead, take baselines for file integrity later, push your artifacts, and then go ahead and move into monitoring. So, like I said, that's a brief recap of what we talked about, but I think that one thing to note that we're going to loop back on a little bit later is that host security and image and container security all in one platform is very, very important. It's a unified platform where you can see everything in one place and look at the entirety of your security posture for your infrastructure. So what we're going to look at now is Acme's made some changes now. So now they are moving to containerization. They are currently in a state of development, and they're planning a move to production. And as I walk through the halls and sort of hear some of the teams, I hear conversations such as, containerization is so much more secure than virtual machines. This is great. We don't need to worry about vulnerabilities anymore. Then I hear somebody else saying, well, I've heard that it's much less secure than virtual machines. And then other people that say, I have a feeling there's a lot of security implications, but I have absolutely no idea what they are. Well, image and container security is a huge topic. There's lots and lots and lots of different areas that we could talk about. We're going to cover a very small part of it today, but a key part. So one of the things that I've noticed, for example, at Container World here in Santa Clara a couple of weeks ago, is I noticed a lot of people that were proactively looking at security, so rather than reactively. And I also noticed a lot of people that just really they weren't sure what they were looking at. They were, they had heard, just like this person said here, I've heard that containers are much, much more secure than virtual machines. And I think that a lot of times what I sort of see is, if we think that containerization is easy, should be a red flag. There's a lot of dangers that are lurking there. And I think that a lot of times, we used to have a hammer to hit ourselves in the foot, and now we've got a big sledgehammer, and we really need to be careful. And so we're going to look at some of those topics today. So one of the things that I've seen is simple visibility or a lack of visibility. We're going to look at a couple different areas today. We're going to look at images. So during the build process and putting up gates there, as well as, so that would be proactive security, as well as continuous security after that. So not just pushing and forgetting, but monitoring what we have as well. We're also going to look at containers, and so running containers off those images, and look at some issues such as identity, configuration, and vulnerabilities. And again, we're going to loop back and talk a little bit about hosts, because really, we're back to where we were before with host level security. We aren't going to get away from that. And some people may say, there are platforms out there where you can run containers and you don't have to worry about the host. We're still working a lot with bare steel. We're still working a lot with private cloud infrastructure. And for the near future, I think that hosts is definitely going to be something that is important to keep in mind. As we continue to move forward, let's look at the build process, just sort of break this out a little bit more before we look at some concrete examples. So the build process, what we're going to do is, again, proactive security. So we're going to look at the state of images before we push. So I want to know if there are any software vulnerabilities in the image before I push it to the registry. So what I'm doing there is simply saying, I'm going to put a gate up, and if there are vulnerabilities within this image, I'm not going to push this, and I'm going to send actionable feedback that says what the problem is so we can fix it, check back into the process, kick off another build, and then push if we've fixed it. The other thing that we're going to do is, once we have that in the registry, who's to say that 6 hours from now, 2 days from now, 3 weeks from now, there aren't going to be problems with that? So we want to monitor what's in our registries as well, and again, get actionable feedback. So as we look at security visibility, we'll start out with the build. So what we're looking at here is a Jenkins job that I have, and it says if there's any critical vulnerabilities greater than 0, so any critical vulnerabilities within the image, I'm going to go ahead and fail that job and send a notification. So what we can do here is, the first step is we can pull an image, we can build an image. use a Jenkins plugin to scan that image for software vulnerabilities, and then have a final step that goes ahead and pushes that to the registry if there are no issues. So we can see here that in the first one that we just looked at, there was an issue with sensible utils. And now we have no issues. So we've gone ahead and remediated that, checked that back in, and there are no issues. And now we're going ahead and tagging that and pushing that to the registry. And we have a successful build. So what we have is a process that says, proactively, I'm going to check this. I'm going to let you know if there's a problem. You can take that feedback, fix it, push it again, and I'm going to let you know that it's fixed. So very direct, actionable feedback. As we continue to move forward, we have our images in the registry now. So we've checked them beforehand, but who knows what's going to happen. Like I said, later today, tomorrow, 3 weeks from now, whatnot. So we want to know continually what's going on with the images. So we want to know if there are new software vulnerabilities. So what we're going to do is we're going to look at how we can continually monitor that. But one thing that I want to take a little side note on today that I don't usually talk about is I have code here that's running that's going to tell me if there are any vulnerabilities in my images. And let's say that I have that running every night. Well, I also have people that are making changes to that code. So I'm depending on that code to let me know what's wrong with the images in my registries so I can have information to know my security posture. So one of the things that I also want to know is that when changes are made to that, I want to ensure that there's a CI process that lets me know that the code is reliable, that it's not broken, and that I'm going to get those reports every night. So I'm going to take a little step back, and there's a bunch of different tools that we can use. I generally talk about Jenkins, Git. There's a bunch of different tools that can be used for CI. And this takes a step back to just say, you know what, I want to ensure that the code that gives me the reports that I need every night is actually working as expected. So what I focus on is, that was an example of Travis CI. And what I focus on is a couple things, style and unit tests. And people may say, well, style doesn't necessarily mean that there are going to be errors in it. Well, slop can lead to slop. And generally what I find is that if I'm following a coding guideline, then I have a better chance of writing quality code rather than if I'm writing things that are sloppy. So the other thing that I do is confirm that anytime there's any changes made to the project, that configuration tests, reporting tests in this example, and the main application are checked for any issues. Actionable feedback. In this example, I get emails. I'm not a real big fan of email feedback, but any kind of feedback can be used. Slack feedback, Jira tickets, Snow tickets, whatnot. Trigger for this is a check-in, so to ensure that the build is always going, and I can ensure that tonight I'm going to get my report that I need for my security. So just another example, Visual Studio Team Services that can be used for CI in that example as well. So just sort of the example that I want to make is that it's also important to ensure that the projects that run these jobs are checked in a CI process, and that there are a lot of different tools that you can use to do that. So continuing on with that example, one of the things that we're going to do is we want feedback that says these are the current issues in the registries with the packages in my images. So what I have is I have a nightly CI job that runs in Jenkins. It could run in another system as well, giving status to Slack. And what it does is it digs down and it tells me, this is the registry or repository tag, and by package and version, it gives me a list of the current CVEs. Now, this ops data can go to any kind of feedback structure. It can go into a ticket, it can go to the SOC, and in that process, somebody can take action on that and can go ahead and remediate the issues at hand. So for continuous security. As we continue to move forward, we're going to move from images in registries to actual running instances of containers. So one of the things that I want to focus on here is that let's say that we have an image and we found a lot of vulnerabilities with it and we've gone ahead and remediated it. Well, who's to say that there aren't a bunch of containers that are already running off that image. So what we're going to do here is the first thing that we're going to look at is identity. So one of the things that is important to understand is, are there containers that are running that are not from registries that you know about, registries that are monitored? And what we do is we call those rogue images or rogue containers. And for example, it may be that somebody pulled down an image from Docker Hub and they're running that, and you want to know that somebody's running that on your system and it's not an approved image. So we will let the customer know if images are rogue. We'll also look at different configuration information, such as if it's writable, if it's running as root. So providing that configuration information for that runtime as well. So one of the things that we've seen is we did a research project a while back. We pulled down about 4,000 images from Docker Hub and evaluated those, some of the most popular images. And one of the things that we noticed was about 93% of those were running as root. About 3% were specified to be running as root. So what that tells me is that 3% of the people thought about it and decided to run as root, and the rest didn't think about it, and it was running as root by default. Also information such as if there's an interactive shell and things such as that. So the last part is vulnerabilities and letting people know if there are any vulnerabilities in the containers that are running. So if an image has been remediated, but there's still, say, for example, 10,000 containers that are out there running from the image before it was remediated. So the piece that hooks all this together is you have information in the portal, and if we want to put it into a Jenkins job, then what we need to do is we need to take that data and we need to massage it and do things that we want to with it. So we have a Python SDK that wraps around our REST API. And the example here is examples of container information that we can get from those calls and that we can do things with. So for example, here, one of the things that I find very important in products for myself is the API robust? Is it well documented? Are the data structures modern and easy to use? One of the real strengths that I find in our product is very robust APIs, modern data structures that are very easy to use. And this is the information that we're getting that we can use to create these reports that give the feedback to the developers and the ops team and the security guys to make the decisions that they need to ensure that they have continuous security and compliance. As we move to wrap up, we talked a little bit about host security earlier. So one of the things that the CIS benchmarks for Docker mention in section 1.2 is host configuration. And again, ensuring that the container host has been hardened. So what we look at here and what we recommend is finding a system where you have one platform that provides information and security for your hosts, as well as your images and the containers that are run from those images. So in one interface and one platform, you're able to automate the security for all these different aspects of your infrastructure. So with that, I want to thank everybody for your time, and I will open it up to any questions that people have.
Great. So if you have a question for Jenks, go ahead and use your control panel there and submit your question, and we'll go ahead and dive right into what we've got so far. Okay, first one. Earlier you mentioned that image and container security is a huge topic and that this webinar will cover a small but key part. What are some other areas related to the topic that you see as important?
Absolutely, thank you. So what we covered here today was some information about software vulnerabilities and images, about configuration and software vulnerabilities and running containers. I think a lot of times it's important to take a step back and say, you know, why are there issues with what I'm using? Why are there issues in my container? Well, a lot of containers, when they're built, are based off of base images. So a lot of times it's a good idea to examine those base images and understand what's in those, understand what you're putting, understand the foundation that's going to go into the container that you're building. Also, I think that some things to pay attention to, and there's, like I said, it's a huge topic. So just a couple things to sort of start to wrap your mind around. Sometimes something to think about is, are you pinning to latest, for example? There can be drifts within latest and nightly builds. So a lot of times it's a good idea to pin to a certain SHA, so you know exactly what you're getting and you know that things aren't going to change. And some other things to pay attention to are issues such as secrets and how those can be exposed. So for example, understanding what a whiteout is and how you address layers can expose secrets, for example. And so there's a lot of different things that can go into those. So taking some time to research and understand the building of images, there's just a lot of things that I think you'll just find that there's more and more to look at. So it's a very large topic, and it definitely is prudent to start to look into it and discover areas where you can improve the process and improve your security.
Okay, great. Our next question, what is the role of Docker in the CI/CD? Are you using Docker to create server images or build software packages?
So what we're looking at is what we're doing is we focus on Docker images and Docker containers. So we're building a Docker image, and that Docker image is going to be pushed into a Docker registry. So whether it's Docker private registry, whether it's Docker trusted registry, Artifactory, whether it's ECR, whatnot, we're going to go ahead and look at that image that's being built. Then that image is going to be pushed into a Docker registry. Then at that point, the images in the Docker registry can be scanned for issues that may have come up since the image was built. And then at that point, we look at images that have been instantiated as running containers, and those would be Docker containers as well. So we're focused specifically on Docker images and images that are running as containers from Docker.
Okay. All right, great. If you have a question for Jenks, go ahead and use your control panel. Go ahead and get it in, and hopefully we'll get to it. The next question, if you see a vulnerable package in an image, how can I investigate and correct the issue?
Excellent. So good question. So I actually ran into an issue a few weeks back where I built an image and I pushed it and I saw some vulnerabilities, and I went back in, and for example, on Ubuntu, there's kind of a cool command called Madison. And what that'll do, if you look at Madison, it will give you the available package versions. And one of the things when I ran this, one of the things that I said, this is interesting. I said, this vulnerability was from a year or two ago, and I don't see any newer packages. This is a bit confusing to me. So one of the things that I noticed was, okay, I'm working with old repositories here. So for example, what I did there was went ahead and did an apt-get update to update my repository lists, and then ran Madison again so I could see the newer versions and then go ahead and remediate that. So that's just sort of an example of one way that you can look into investigation and remediation of a vulnerability.
Okay, great. Our next question, how is scanning automated in the CI/CD pipeline? Are we using any RESTful APIs in the process?
So absolutely. So the way that the scanning is done, so there's a couple different things that we covered here. So in the build process, so the way that the scanning is done is we go ahead. I have 3 stages in my build process. So I either pull or I build an image, and then I use a Jenkins plugin that pulls down a container from Cloud Passage that goes ahead and does the scanning there from within the container. And that's using our REST API to do the scans. And then, for example, in the monitoring, what we go ahead and do is, again, I'm using the REST API to go ahead and get the vulnerable information from the last scans. So exactly what we're doing is we're using the RESTful API or the Python SDK to go ahead and put these, it's the glue between the two, between the products. So absolutely.
Okay, great. So I have kind of a 2 or 3-parter question here. So bear with me here. It's long. So
Cool.
okay, so the first one is, it was asserted on slide 3 that security turn up at the 11th hour to lay down a raft of security blockers. From my experience over the last 4 or 5 years, this is a facile perception that allows developers to dismiss security concerns as blockers. My experience is that security is always willing to get involved from the get-go. What has changed is that more recently the industry has applied more thought to non-functional requirements, QED, your presentation. That's a thought. Moving ahead, interesting statistic, 200 devs to every security resource. What are your thoughts on those two comments, I guess, rather than questions?
I think it's fantastic. The thing that really resonated to me is absolutely 200 devs to one security resource, where you have, you may have a multinational firm and you have 3 security people in the entire firm. I think that, I take a step back. So I think it's interesting thoughts and interesting questions. One of the things that I see is there's a huge spectrum of complete block of security, all the way to companies that really have integrated a lot of this into the process. And I think a lot of it is simply understanding the different options that are available. For example, I think that there's a lot of confusion in people moving to the cloud, people moving to containers, and even if things are very similar in security, a lot of times we have this idea in our head about how things are done, and it's very difficult to wrap our heads around how things can be done differently. So I find that sometimes talking about, for example, IP addressing and firewall ruling, and how when IP addresses change when we're in a public cloud infrastructure, that how we can automate that so we don't need the 5-day SLA to assign these firewall rules, how we can orchestrate that. So I think a lot of it is educating and bringing people together to understand how we can pull these processes into an automated fashion. I think that everybody does want to work together. A lot of times it's just a sense of understanding how we can work together and really focusing on a solution, as opposed to, well, this isn't going to work in this environment, so let's waive it for dev, and we'll worry about it later when we get to a different environment. But I think that a lot of times the problem that we're talking about, as far as, one security person to 200 devs, is one of the reasons that tools that can automate security become such a powerhouse, and how they can be used as a toolbox, is because it's able to leverage the small amount of security resources with the extreme tidal wave of development that's coming ahead. And if you can put all that into a process where the developer checks something in and gets a quick note that says, hey, there's a problem, this is how we can fix this, there's a process to fix it very quickly, then at that point, everybody works together to get the flow sort of all in the same direction, I guess. So it's a complicated question. And I hope that was helpful to shed some light on it.
Yeah, I think that's probably, rather than a question and answer, I think that's probably a half-an-hour conversation, at least over beers or something like that. And
anybody that wants to talk about anything further, my email address is up on the screen. Please contact me. I'm happy to talk about any of this in further detail. I'd also love to talk about, disagreements that people have, how things can be improved, your thoughts. It's an interesting topic.
Yeah, absolutely. Absolutely. Okay, I've got a couple more questions here for you. At the end, you mentioned host security, but did not go into detail. Can you elaborate on that a little bit?
Absolutely, absolutely. So I think that something that's important is there are some conceptions that containerization, is much safer, and you don't need to worry about the host anymore. One of the things that I noted is that the CIS benchmarks for Docker do mention that the host needs to be hardened. And, one of the things that I talked about earlier was that out of those 4,000 images that we pulled down from Docker Hub, about 93% of those were running as root, and with about 3% where root was specified. Now, I'm not saying that, people are going to be able to break out of those containers, but with statistics like that, you have a higher ability to break out of that container if you're running as root. And if you break out of the container, you're on the host. And so just something to be aware of. And I generally find that if you have a platform where you can focus on your security all in one place, it generally makes it a smoother process than trying to pull a bunch of different tools together and look at host security in one place on one interface with one API, and looking at container and image security in one place with a different API. It brings a toolbox that you can use with everything in one place to really look at the threat landscape and evaluate your security posture and how you can improve it.
All right, great. Okay, there's still time, guys. If you have a question for Jenks, just go ahead and use that control panel and get your question in. We've got another question here. Are you using Chef for pushing the infra server updates? And then how are Docker and Chef used together?
Absolutely. So that's a good question. So to start out, so the way that, yes, Chef can be used to push updates. Myself, generally, what I'll do in my examples, we generally use Puppet. I've used Ansible before to push updates. As far as I'm not currently using Chef with Docker, there's a lot of different things that you can do. For example, when I do in my host security, I use Chef to kick off the AMIs. So I can go ahead and launch those and run scans on there. And I think the point is that there's a lot of different things that you can do with Chef, a lot of different things you can do with other tools, and those are some of the ways that I'm using them. I have not investigated at this point using those with any of the container work that I'm doing, but that's definitely something that is interesting to look at in the future.
All right, great. Well, I think that is all of the questions that we have. Jenks, I want to thank you very much for giving us such a great presentation. I also want to thank the audience for submitting your questions and for attending today's webinar. Today's webinar, as I mentioned earlier, is being recorded. So if you missed any or all of it, you will be receiving that link on demand to listen to the webinar. Also, Jenks, you had mentioned at the beginning of the presentation that this was kind of a follow-on, or part two, if you will, of an earlier Cloud Passage presentation webinar. So we're actually going to be including in the follow-up email some hyperlinks for you guys to access that information to kind of give a deeper and a little more comprehensive look. Just also know that the webinar is, in addition to the link that you'll be receiving, you can also access the webinar on devops.com. And while you're there, check out all of our other webinars that we have listed, upcoming and on demand. And again, Jenks, thank you so much for your great presentation. It was, I'm sure the audience got a lot out of it. I know I did. So thanks very much.
Absolutely, thank you.
Great. And thanks again to the audience for attending today's webinar. And I'm Charlene O'Hanlon signing off. Have a great day.